Okay, we'll continue the theme for magnetic, but this time with SPIRou. So, Lisa Drouglazet.
So, good morning, everyone. My name is Lisa Drouglazet. I'm a second-year PhD student working with Université in Grenoble on the characterization of magnetic field in class 1 protostars. So, in this presentation, I will show you my analysis of SPIRou data. So, magnetism has been well studied in the class 2 protostars, and magnetic field play an important role at large scale in the process of magnetospheric accretion and star disk interaction. The magnetic properties are resumed in this confused diagram that I will not detail here by lack of time. The class 1 are the progenitor of the class 2, and we may wonder if the magnetospheric accretion happened at this stage and how, and if the magnetic property can be compared to the class 2. So answering those questions are the objective of the Prométhée project led by Evelyne Alessian. With this project, we obtained a sample of 16 class 1 and flat spectrum protostars that we indicated on this HR diagram. So the solid black line are the evolutionary tracks for at different masses, and in green at different age. So as we do not have information about the luminosity, we suppose an age inferior to 1 million years for our sample. And the red circle is from previous analysis of classical T-Tauri stars. For each star, we obtain observation containing intensity and V-polarized spectra. So with those observations, we compute the LSD profile using the spectral flow pipeline. So on the first example, you can see the intensity, the null profile, and the circular polarization. And we have a magnetic detection because the signal is significantly non-null compared to the noise. On the other example, we do not have detection because you only see noise. So for each star, we compute the longitudinal magnetic field value. So the line of sight component of the magnetic field integrated over the surface. And we try to see the link between magnetic detection and stellar parameter. So on the x-axis, you can see the effective temperature, and on the y, the rotational velocity. The size of the symbol are proportional to the value of the longitudinal magnetic field value for the magnetic stars, and for the non-magnetic, it's the uncertainty on this value. So it's interesting to see that we can detect a magnetic field at a very high velocity, and we do not have any observational bias in our sample. So to conclude, in the sample of 16 class 1 protostars, we have 5 stars without magnetic detection, on which we compute the upper limit on the magnetic strength, and 10 protostars with detected magnetic field. So those are ZDI candidates, and the perspective of my work is to do Zeeman Doppler imaging for 4 stars in which we have data, and you can see preliminary results. Thank you.
Question for Lisa?
I'm just curious, are the protostars with no magnetic detection on the younger side of your sample? Can we interpret that as a result of they're too young to have developed? Time to develop those.
Detected protostars are the youngest?
Yes. One without magnetic detection. Are they the youngest?
Not necessarily.
Okay.
It's we don't know.
Okay, thank you.
Okay, let's thank our speaker again.